We're here on the banks of, or up above, what is actually the Illinois River, and we had about an inch or so of snow last night. It's a nice brisk wind up here, or a little chilly air, but what we're all about here today is to bring you live to the Cold Land Processes Experiment, or CLPX. Well, we are going to go into a little detail on those ISAs, but to do that, we're going to throw it on down to Steve and Kelly Elder down at our other location. And Steve, can you hear me down there?
We hear you down
You're
here,
waving
Kathy.
to us?
We're waving. How are you doing up there?
We're fine and dandy and all set for, we got everything all warmed up for you. I thought you'd appreciate that.
It sounded really great from down here. It sounds like it's a little windier up there, but thank you for everything.
Okay.
Thanks, Don.
Take it over.
Great, much appreciated. Great big Colorado hello to everybody watching in our audience.
What we're going to measure here are the exact same things that we measure at all the ISAs. We want comparable data at all the points, so we're going to measure the same parameters. What you have to do in an area like this, though, with shallow snow, is adjust a few of your measurements or your measurement techniques to get the same information, but with tools that will actually measure it here. Do you want to just go ahead and go through the routine that we do here?
Yeah, I think that's going to be our best bet.
Collect some of the data and show people.
Let's go ahead and check it out.
Okay, you guys note that the snow is very shallow. You can see the grass coming right through here where we're going to do this. Normally, when we're doing snow density pits in deeper snow, we use this wedge-shaped cutter, but it's 10 centimeters by 10 centimeters on the back, so you have to have at least 10 centimeters to use it. Typically, the ground's rough, so we have a different technique that we use anytime the snow is less than 15 centimeters deep. And what we use for that is a tool called a SIPRI tube. It's a very old tool in snow and glaciological sciences. And it's just a tool with a stainless steel piece of tubing with a beveled edge that will cut through ice. And so what we do is first tear that to get the initial weight. I'll turn this so you can see that. And we push the tear button and we should get a 0 there. Okay, now that tube weighs nothing in the scale's mind. Okay, we scrape away the snow from the side and we slide this tube in the edge here, insert the cutter, pull the whole thing out, clean it off, and then we'll slide this right onto the scale. 10 centimeters of snow.
Okay, 10 centimeters and a mass.
And the mass is 38 grams.
38 grams. So why is it important to know here the mass and the depth?
Okay, mass plus the depth give you the water equivalence. And the cutter that we use in deeper pits gives you that value in kilograms per meter cubed right off the bat because it's a standard size. We know the dimension of this tube, and with the height we can calculate the volume. Then with the mass we can go ahead and get a density. We can't do that right here in our heads with this tube. That's something we'll calculate later.